Okay, good afternoon to all. Today we will start the unit number 4, linear transformation. Okay, in the last lecture we seen that what is the definition of basis, okay, and what is the dimension. What is the dimension? The number of elements in the basis set is called as a dimension. And some remarks on the basis. Okay, so today we will start unit number 4. Okay, last unit of our syllabus, linear transformation. Unit number 4, linear transformation. Okay, before going to see the definition of linear transformation, we will see some basic definitions. Okay, what is mean by transformation? What is transformation? Look at it. Definition of transformation. Suppose two sets are there. Okay, suppose X and capital Y. Capital X and capital Y are two given sets. Okay, two given sets. Okay, if each element of X, each element of X belongs to capital X corresponds to corresponds to a unique element, to a unique element y, small y belongs to capital Y. Okay, by some given rule. Some given rule. Okay, what is transformation? Suppose X and Y are the two sets given. If each element X belongs to X corresponds to a unique element to Y, small y belongs to capital Y by some given rule. Okay, then that rule is called that rule is called transformation of X into Y. Then that rule is called transformation. Okay, transformation of capital X into capital Y, and it is denoted by it is denoted by small f. Okay, what is the transformation? Suppose X and Y are the two sets given. If suppose this one is X set, okay, capital X, and this one is the set Y. So each and every element of X, suppose this is X, small x, okay, small x1 or small x2 are the elements of capital X, is correspond to unique element of Y. Okay, this element corresponds to unique element of Y. Suppose this is Y1. So this X is related to this Y1. X1 is related to here Y1. Okay, by some given rule, and that rule is called as F. Okay, so here the X belongs to X corresponds to a unique element Y belongs to Y by some given rule, and that rule is nothing but what? Transformation of X into Y. Okay, so every element of X, capital X, is transformed to set into the set Y. Okay, and that rule is called as transformation, and it is denoted by this F. Okay, and we write that transformation. Okay, F from X to Y. Okay, so here the F is the mapping from X to Y. Okay, and this one is read as how we are going to read this one? F maps capital X into capital Y. Okay, or we can read as a f is a transformation. Small f is a transformation. Small f is a transformation, or we can say it mapping. We can say the transformation or mapping of x, capital X, into capital Y. Okay, so this is the definition of what? Transformation. Okay, now some more concepts are there. Look at this one. Suppose an element. Suppose an element y, which belongs to capital Y. Okay, this Y is corresponded by an element x, by an element small x which is belongs to capital X. Okay, under the map, under the map. Which one under the map? Small f. Okay, so this y is corresponded by an element this small x. Then we called y this y. Okay, then y, that small y, is called image of x. Okay, image of that small x. Okay, now look at here in the diagram. Here x1 is related to here y1 by the mapping f. So y1 is what? Image of x. And we can write this statement: f of x1 is equal to y1. Okay, what is f of x1? F of x1, that x1 is related to y1 here. So f of x1 is equal to y1, and this y1 is called as image of this x1. Okay, so here we taken as a x1 as x and y1 as y. So y belongs to y corresponded by an element small x belongs to capital X under the map small f. Then y is called as image of x. Okay, and it is denoted by, and it is denoted by f of x. Okay, thus we get f of x is equal to y. Okay, any doubt? So here the y is what? Y is the image of x, and here y is the image of x, and here the small x is defined as the pre-image of y, pre-image of that small y. Okay, now if f of x is equal to y, then we can say that this y is image of x, and this x is pre-image of y. Okay, what is y? Y is image of x, and x is what? Pre-image of this y. Okay, it is clear now? So this is the transformation of x into y. Okay, so thus the set, here the set x is called as domain. Okay, this x, set x, is called as domain, and this set y is called as codomain. Okay, so write down here. So what is x? Thus the set capital X, okay, and the set capital Y are defined as or we called as domain, domain and codomain, domain and codomain of the function or of the mapping of this function f. Okay, here set x is called as domain of that function, and set y is called as codomain of that function, respectively. Okay, any doubt up to here? Any doubt up to here? Reply there. Okay, now the f of x is called small f of x is called which is equal to y na, y is equal to f of x. It's called hmm, image. Okay, image of x or image of f or range of f. Okay, y is equal to f of x. What is it called? It's called image or range of that function. Okay, so what is f of x? So evidently, we can define this f of x is equal to, sorry, capital F of x. If you, the range set of all the domain is equal to, what is that set? Take the f of x. Okay, element of the type f of x, where this x belongs to capital X. Okay, or we can write what is f of x? It's y, na? So here f of x is equal to y such that y is equal to f of x for some x belongs to capital X. Okay, so this is the f of capital X. And also we have this f of capital X must be contained in capital Y. Okay, now look at here. Suppose this is the set X. Okay, capital X. And this one is capital Y. Suppose these are this number of elements. Okay, how many elements? Suppose it's x1, x2, x3, x4, and x5. Okay, so here the x1 is related to here. Suppose y1. x2 is related to y2. x3 is also related to y2. Okay, x4 is related to y3. Okay, this is the element y3. And x5 also related to what? Y3, and some more elements are there. This is y4. Okay, so here the set X contain 5 elements, set Y contain 4 elements. Okay, so this is the mapping F. So what is F of capital X? F of capital X is the set. X1 is related to Y1, so here the Y1 comes. X2 is related to Y2. Okay, X3 is also related to Y2. Okay, so no need to write once again the Y2 element. X3 related to Y2, X4 related to here Y3, and X5 is related to Y3 again. Okay, so no need to write again. So here f of x is what? Y1, Y2, Y3. But what is Y? Capital Y is what? Y1, Y2, Y3, Y4, and Y5. So there are 5 elements are there in set Y. Okay, so here the f of capital X is what? Subset of this capital Y. Okay, which here this step. So what is f of x? Take the elements from the set Y such that Y is equal to f of x for some x belongs to capital X. Okay, any doubt up to here? Okay, now the next is remark is there. What is that remark? Look at it. From the definition of map, okay, from that f is called what? F is called as function, mapping. Okay, they are all the words are equivalent. What is f? The small f is called function, okay, or transformation, okay, or map, or mapping, these all are equal or equivalent. Okay. So from the definition, hmm, from the definition of a map, it is clear, it is clear that a map or a mapping or a transformation, anyone, f from set x to y is said to be is said to be well defined. कधी well defined होईल हा सेट फंक्शन मॅपिंग फर्स्ट वन any x belongs to capital X. It implies f of x must be the element of capital Y. Okay. Second one, any small x belongs to capital X. A unique element असायला हवा तो. Okay. Unique, a unique element f of x belongs to capital Y. Okay, now look at here. So here the x1 is related to what? X1 related to here the y1. Okay, so the image of x1 is what? Unique x1. So here we have do not have a the image of x1 are two images of x1. Okay, so image of x1 must be unique in y. ओके म्हणजे या एक्स वनची इमेज इथे वाय मध्ये ही युनिक असायला हवी. एक्स वनच्या दोन दोन इमेज असून चालणार नाही. ओके सो हियर x1 is related to unique element in y. Okay, for every element of x, capital X. Okay, so here the x1 is the member of capital X. This x1 is related to unique element of y. Okay, here the x2 is related to unique element in y2. x3 is related to unique element in y, that is y2. Okay, now f of x belongs to capital Y. What is the meaning of this word? This sentence? In other words, we can say that in other words, no element of capital X may have more than one F image. Okay, what is the meaning of this sentence? If any x belongs to x, we have unique element in y, that is f of x. That is, no element of x may have more than one f image. Okay, we cannot find two or more than two elements y1 and y2 belongs to y. Okay, now and third one, two or more than two elements of x. Okay, two or more than two elements of x may have the same image, may have the same image in capital Y. That is, if x1, x2 up to so on xn, okay, and up to so on belongs to capital X, then f of x1 is equal to f of x2 is equal to up to so on f of xn, okay, up to so on. This may be possible. Okay, for two or more than two elements of x, we may have the same image in y. Look at here. The image of x3 and x4. Okay, look at here. The image of x2 and x3. What is the image of x3 and x3? x3 is y2. image and y3, y4 and x4 and x4, x5. Okay, here the image of x4 and x5 we have y3. Okay, more than here the two elements of x may have the same image in capital Y. But in x, every element in x we have unique image in y. Okay, now so this is the transformation, this is the mapping, this is the function. Okay, now we will move towards the next point, onto or into mapping. What is the mean by onto function or into function, or onto mapping or into mapping? The next definition is what? Onto transformation, onto and into mapping, or we can say that function or transformation. All these words are equivalent. Okay, what is onto and into mapping? Look at here, the definition. What is the definition of onto and into mapping? Let this small f is the function from, or the transformation from x to y be a map. Okay, suppose this is a mapping, and f is called an into mapping, into, or this map into, the other words for into is injective map. Sometimes we call it as a injective. Okay, then another word for into is injective. So let f is the function from x to y be a map, then f is called into or injective mapping if there exists at least if there exists at least one element, okay, at least one element in capital Y which has which has not a pre-image of x. Okay, what is the definition? Let f is the mapping, f is the transformation from x to y, and f is called as into mapping or injective mapping if there exists at least one element in capital Y which has not a pre-image of x. Okay, sorry, not of, in x. Okay, which has not a pre-image in capital X. And look at this one. What is the meaning of intoness? Suppose this is set x and this is set y. Okay, one, two, three. These are the three elements in x. Okay, and this one is, suppose this is a, b, c, d. And also is the fourth. There are four elements in set x, and here the four elements also in set y. Okay, now what is the definition of into mapping? Suppose this is the mapping. Here the one is related to a, two is related to b, three maps to c, and also the fourth element of this set x also maps to, suppose, c. Okay, so here there exists at least one element D belongs to what? Y, capital Y, such that for that element D, we not have a pre-image in X. Okay, suppose this is the mapping F. Okay, so here the in codomain, this is the domain. This is codomain. Okay, so here the element D, this element D belongs to here the Y. At least काय म्हणते definition काय? What is the definition? F is called as into or injective. There exists at least one. कमीत कमी एक तरी element in Y. Okay, here the D is the element from Y which has not pre-image in X. Okay, so here the D is not related for any element of X. So hence this mapping is called into mapping. Okay, so this is the definition of what? Into. Wait a minute. Okay, now what is the now onto mapping? Look at the definition of onto. And this small f is said to be, small f is said to be an onto map. Okay, if f of capital X is equal to capital Y. What is the meaning of this one? That is, every element in Y, capital Y, has pre-image. Okay, pre-image in capital X. Look at this. Now here the set X. This is the set Y. Now these are the four elements in X. 1, 2, 3, and 4. Okay, instead of writing here, write here. This is 1, 2, 3, 4. Okay, now here also the four elements are there. A, B, C, D. Okay, now here look at here. 1 is related to A, 2 is related to B, 3 is maps to C or related maps or transformed, or 4 is transformed to D. Also suppose the fifth element is there in X and this fifth is also transformed to D. Okay, now look at here in the set Y. Hmm. Every element in Y, every element of in Y, what? How many elements? A, B, C, D. These are the four elements in Y. So the all the four elements in Y, there is a pre-image in capital X. Okay, so A is a pre-image कोण असेल? 1. Okay, what is the pre-image of B is 2. What is the pre-image of C is 3. What is the pre-image of D is 4 and 5. Okay, so each and every element of Y is has a pre-image in X. Okay, then that mapping F or transformation is called as onto. Okay, that transformation is called as onto mapping. So this is the definition of onto mapping and into mapping. What is the range set of this F? Range of F. Range of F is nothing but all the elements. We seen that what is the range of F. Look at here. What is the range of F? Take the element Y belongs to capital Y. Y belongs to capital Y such that Y is equal to F of X, where this X belongs to capital X. Okay, so here, what is the range of F? This is the domain. This is codomain. How many elements in codomain? 4 elements. Okay, so what is the range set? Range set means collection of these elements, collection of the codomain elements which has a pre-image in X. Okay, so how many elements are there in Y? 4 elements. Okay, so how many elements has a pre-image in X? 4 elements again. A, B, C and D, which is nothing but whole set Y. Okay, so here range of f is equal to what? Y. Whole set y. Hence, if suppose f is onto function, okay, or onto transformation, then range of f is equal to what? Y is nothing but codomain. Okay, if suppose any function is given to us which is onto, then range of that function is must be is equal to codomain of f. Okay, range of f is equal to what? Codomain of f. When it happens? When f is an onto function. Okay, now the next definition is one and many one function. One and many one map. Okay, next definition. One and many one transformation or maps. ओके, अजून आपण लिनियर ट्रान्सफॉर्मेशन कडे गेलो नाही, आपण फक्त ट्रान्सफॉर्मेशन बघतोय. ओके, ट्रान्सफॉर्मेशन. Okay, what is the meaning of many one transformation and one transformation? Look at this one. Let let f is the mapping from A to B. Okay, be a map. Right now, be a map. Then f is called a one map. Is a one map if f of A is equal to f of B, where A and B belongs to A. This implies A must be equal to B. Okay, what is the meaning of this one? Suppose here, let f be the function or be a map from A to B. Then f is called one map. Okay, when we are going to say this f is one, if f of A is equal to f of B or AB belongs to A, that implies A must be equal to B. ओके, जर आपण एफ ऑफ ए इज इक्वल टू एफ ऑफ बी घेतला तर काय होईल? तो ए इज इक्वल टू बी. म्हणजेच काय? लुक ॲट. Suppose this is the set A now. This is the set B now. Okay, here 1, 2, 3, 4. And this one is A, B, C, D. These are the four elements. Suppose, okay, suppose these are the four elements. So here 1 is mapped to A, 2 is mapped to B, 3 is mapped to C, okay, and 4 is maps to D, and this is the function f. Okay, when we say that this function f is one, this condition f of A is equal to f of B, then where A and B belongs to A, then A must be is equal to B. Okay, what is the negation of this one? Negation of this one. If A is not equal to B, this implies f of A is not equal to f of B. That means different images, different element have different images. Sorry, different images have different element. Okay, if A is not equal to B, that means for here set A मध्ये कसे एलिमेंट्स आहेत तुमचे? राईट, सॉरी, वेट. Suppose A is the set A, B, C, D. Now it is clear. And set B contain 1, 2, 3, 4. Okay, 4 elements. So here 1 maps to A maps to 1, B maps to 2, C maps to 3, and D maps to 4. Suppose. Okay, so this is the function f. When f is called one map, f of A is equal to f of B, or AB belongs to A, then it implies A is equal to B. What is the negation of this statement? If A is not equal to B, Okay, if we know that P implies Q, that means negation of Q implies negation of P. Okay, so if A is not equal to B, that implies f of A is not equal to f of B. Okay, suppose these are the two elements. Okay, both are distinct elements, both are not equal. What are the images? A is maps to, what is f of A? A maps to 1. What is f of B? Is 2. Here, hmm, A is not equal to B. Hence, hmm, f of A is not also not equal to f of B. What is f of A? 1 is not equal to 2. Okay. Both are also here distinct. Okay. Hence, this function is 1 1 function. नावातच आहे त्याच्या 1 1. एक एलिमेंट एकालाच तिकडे इमेज हवा आहे. Okay. Unique image पाहिजे. Okay, now look at it. If suppose this function is like this, if suppose this b maps to a 1, मग हा function 1 होईल का? No. Okay, here the a and b are different, but their images are same. Okay, here a and b are different, two distinct elements in set A. Okay, but their image, what is the image of A? 1. What is the image of B? Is also 1. Okay, so here f of A is equal to f of B. Since A is not equal to B, but f of A is equal to f of B in this case. So this function is not 1 1. Then if the function is not 1 1, then that function is called as many one function. Many elements are, hmm, many elements in A have image, one image in B. Okay, so wait a minute. Okay, now this one related to here 1. Okay, one element related to one element. So this function is 1 1. Okay, now look at here. This is set A. This one is set B. There are 4 elements: 1, A, B, C, D. Okay, and also here the 4 elements are there: 1, 2, 3, 4. Here 1 maps to 1, B maps to 1, C maps to also 1, D maps to suppose 2. Okay, here the A, B, C, many elements maps to one element. Okay, so this maps is called as many one map or many one function. Okay, so what is the definition of 1 1? Let f is the function from A to B be a map, then f is called 1 1 map. If f of A is equal to f of B, it implies A is equal to B. That means different images, different element have different images. Okay, now they write down the definition of many one function. Okay, what is the meaning of 1 1 function? 1 1 map, that implies different elements, different elements in capital A have different images in capital B. Okay, and the next definition, another definition is what? Many one. What is the definition of many one function? F is called many one map. Okay, different if different elements, okay, if different elements in capital A have the same image, same F image, okay, not image, F image in capital B. That is, what is the meaning of this sentence? If f of A is equal to f of B, for A and B belongs to A, that implies A is not equal to B in this case. Okay, what is f of A? 1. What is f of B? Also 1. What is A? Here A and B and C. The both all the three elements are different, but their images are same. Okay, so this is the definition of main even function. Look at the example. If you take example, then it is clear to understand. Examples. The map, the map f from set of real number to set of real number given by given by f of x is equal to x cube, where x belongs to what? Set of real number is on to, sorry, is 1 1 and on to map. Look at here. What are the real numbers? 1, 2, 3. Okay, real line. Okay, if you take any element on the real line, hmm, f of 1 is equal to, put instead of x here 1. So 1 cube is equal to 1. F of 2 is equal to 2 cube is equal to 8. Okay, so here f of 1 is not equal to f of 2. Okay, that is 1 is not equal to 8. So this implies, what is a here? 1. What is b here? 2. So 1 is not equal to also 2. Okay, hence for any a and b belongs to capital R, we have f of a is not equal to f of b. Okay, for a and b belongs to R, that implies a is not equal to b. Okay, if you take different images, that is 1 and 8 are not equal, hence it implies 1 and 2 is also not equal. Okay, for that is f of a is not equal to f of b, that implies a is not equal to b. Okay, हे example घेतलं आपण एक आणि दोन. Okay, you can take any element from the R. Hence, f of x is equal to x cube. It's 1 1 onto map. Okay, any doubt? Go ahead.
No, sir.
Any doubt up to here? This
No,
function is
sir.
not 1 2. Okay, only 1 1 is there. So f of x is equal to x cube is 1 1 now. Okay. Now the second example is, look at this. Second one. The map f from set of real number to set of real number. Okay, given by f of x is equal to x square, where x belongs to capital R. Is not 1 1. Why not 1 1? Not 1 1 function. Is many one function. Why this function is many one function? Look at here. What is f of x? Is equal to x square. What is f of 2? Put instead of x 2. So here 2 square is equal to 4. What is f of minus 2? Again, minus 2 square, which is equal to 4. Hence, there exists an element 2 and minus 2 belongs to capital R. Okay, such that f of 2 is equal to f of minus 2. Okay, 4 is equal to 4. That is f of 2 is equal to f of minus 2. But 2 is not equal to minus 2. Okay, so here hmm, 2 also maps to 4. Minus 2 also maps to 4. Okay, so hence hmm, f of 2 is equal to f of minus 2. But 2 is not equal to minus 2. So this is the definition of what? Look at here. F of A is equal to f of B. That implies A is not equal to B. This is the function of, this is the type of main even function. Okay. So hence, f of x is equal to x square is many one map. Okay. Any doubt up to here? Okay. So for today, it is sufficient now. Okay, in the next lecture, we will see some more definitions. What is the equal function, equal transformation, inverse mapping, product of two functions, and hence we come at a linear transformation. Okay, so for today, it is sufficient now. Okay, any doubt up to here?